Hello, everybody, and welcome back. As a reminder, if I forget to start this recording at the beginning of the class, please remind me, because otherwise you won't have any recordings of lecture to be able to watch later if you want to be able to do that. I did make a request about the temperature in the room to turn it down, so hopefully they'll get through that soon and it won't be so hot in here, because it was really bad yesterday and still is a bit uncomfortable today. In other news, your first homework assignment is up, right? It's on Codathon, so make sure you're paying attention for assignments. That's where they're going to be posted at. So be watching that. The first one's just a tutorial, so just follow along with the instructions. I think one of the commands isn't working, like R uptime, so just skip it. Shouldn't be too hard to complete, but it's free points, so make sure you do get it in because it still does count as an assignment. Any questions before we get started? I did start the recording. Yeah, I just did it right before we started. Other things, we did get our course expansion, so some of you guys should have seen that you got off the wait list, but this is pretty much as big as we're going to be able to make the course. So if you're not in right now, probably the only way you're going to get in is if somebody in the course drops, but that's fairly unlikely. So definitely have a backup class and probably be thinking that your backup class is more like your real class and this is your backup class in terms of how you're behaving. So we'll pick up from where we left off yesterday. As some of you guys noted that the first time you log into the CSIF, if that's where you're doing your work, when it goes to ask you to type your password, it won't show up. That's perfectly normal. It's there to protect your password, right? If anybody was looking over your shoulder at your screen when you were typing your password, no one would be able to even know how long it was, right? Unless they were like watching you type. That'd probably be a little bit uncomfortable and you'd probably notice that. So we talked about CD yesterday. So again, here's just some examples of paths, right? Remember, there's absolute paths, which are from the beginning of the file system. The beginning of file system on Unix machine starts with // On a Windows machine, it's going to be like C:, or D:, the name of the drive that you want to work on, right? So in this example, we're going to assume that our current working directory is /opt/unbundled/app1. So /opt/unbundled/app1, right? What command could we run to figure out what our working directory was? PWD, right? Print the working directory. And that's how we know that we were actually here right now, right? So let's say we wanted to get to file 1 inside of app1. Well, the absolute path to file 1 inside app1 is /opt/unbundled/app1/file1. But if we want the relative path, it's just file 1 because we're already inside app1 over here. So let's say we wanted to get to the file 3 in app2. The absolute path again from the beginning is /opt/unbundled/app2/file3. But since we're currently in app1, if we wanted to use a relative path, we'd have to go up one level, ... right? Then app2, then file 3. What would be the absolute path to system over here? /etc/system, right? Again, if we assume that we're still in app1, what would our relative path be to system? Not // but ... right? Because we need to go up one level. If we do ... that's going to bring us into unbundled. No, we're currently in app1 right now. So going ... is going to bring us up into unbundled, right? Then from here, we'd have to go up again, right? So /... would bring us into opt. Then /... would bring us back into the root. Then /etc., right? /system, right? So which path is actually going to be shorter, the relative path or the absolute path, is really going to depend like how far away each of these things in. The relative path is going to be shorter if you're pretty close to that file, right? The absolute path might be easier to use if it's very far away from where you're currently at. Does that make sense? Are there any questions about relative paths or absolute paths? Okay. So let's say you want to display the contents of a file. That's cat file name, and it will show you everything inside that file. Head is used to look at the first couple of lines of a file. So you can say head, optionally give -n, and then some number of lines to display in the file name. If you don't give a number, by default, it's going to display the first 10 lines of that file. If there are less than 10 lines in that file, it's going to display all of them. Tail displays the last couple of lines in a file. Again, -n will let you specify how many you want to see. And if you don't give a number, by default, it'll be the last 10 lines of the file. So ls will cd into maybe like ECS 50. We'll cd back into examples. Again, tab helps you complete the commands very quickly. So if I do cat, say, mat add.s, I can see everything that's in that file, right? Which there's a lot of stuff. If I want to clear my screen, again, that's just clear. That'll knock it off. If we just want to see the first couple of lines of mat add.s, we can say head. If we wanted to see a few fewer, we could do -n5. And that would just give us the first line. And if we do tail, right, it would give us the last couple of lines. Again, it doesn't have to be like a relative path. It could be an absolute path. If I go back into my home directory, right, I could do something like head, examples /cmatadd/cmatadd/matadd.s, and again, I would see the files that are in there. Which again, this could be quite a bit quicker once you get comfortable with it, and you realize to press tab a whole bunch, than going through and clicking through all the files on your file browser to get to where you need to be. Does that make sense? Yeah. The .s is for assembly files. Come to ECS 50 if you're interested in learning more about that. Yeah. I can try to increase duration. Okay, so I have to, I think, exit this one and then try again. Is that any bigger? I don't think so, right? Well, I would have thought making the size 16 bigger. Can I do this? Oh, well. Okay, it's probably a bit too much. Okay, well, we'll try to go a little bit slower. Is that big enough, or do you need bigger? Good, or a little bit bigger? A little bit bigger? Good? Okay. Yeah, if something's too small, let me know, and I'll try to fix it. So any other questions? Okay. So let's say you want to copy a file. CP is the command that you would use to do that. So you say copy some file name, some other file that you want to put to, and it'll make a copy of that file. One question I have right now is, do file names need to be unique inside your file system? Yes, file names do need to be unique inside the file system. No, they do not. What's my other option? It's either they have to be unique or they don't have to be unique. There can't be any middle ground. So who thinks they need to be unique? Who thinks they don't have to be unique? if they don't have to be unique, is there anything that needs to be unique inside the file system? The absolute path, right, to a file needs to be unique. So make sure that when you're copying something, that whatever you copy it to, you have to have a unique absolute path. So you can't say like copy file 1 into like file 1 inside the same directory, because then there'd be two files that have the exact same absolute path. You can also copy multiple files from one directory to another directory by listing all the files, then specifying a directory. That directory has to exist to be able to copy those files there, and you'll get a copy of it there. When you copy one file to another, if it doesn't exist, it'll create the file. If it does exist, it'll overwrite the file that already happens to be there with the same name. So, like, let's say I wanted to copy, that mat_add /cmat_add/mat_add.s, and I could copy it here to my current directory, right? So if I list this directory, you can see that there's no mat_add.s here, and now there is a mat_add.s. Using the second form, copy that file to here, right? Now that I have mat_add.s, I could say, copy mat_add.s to cmat_add.s, and now I'll have a cmat_add.s here as well. Right? And if there are multiple files, right, I'll make another directory called garbage. So I'll get rid of it later. So I could say like copy cmat_add.s, main.cpp, and mat_add.s all to garbage. And then if we look inside garbage, that stuff's there. So you can see that like doing some of these commands can be a lot faster than actually doing it by like dragging and dropping. Like, how do I know where the file is at that I want to copy?
How do you know which one? Oh, is it the backslash?
So again, if we look at the syntax here, right, there's two different forms. The first one is the file that you want to copy, and then where do you want to copy it to, right? And this des file name can be a path. This can also be a path, right? It doesn't just have to be a single name, right? So the second thing, or I should say the very last thing, specifies where to copy it to, right? If we use the second form, which I did on the last command, right, I copied a couple different files to some directory, right? And since the directory is the last one to be listed, these three files are copied to this directory. It's just the last thing is where it gets copied to. Any other questions? Okay, so move is used for two different things. It's used to both move files around inside the file system as well as to rename files. So if you do move old file name to new file name, change the name from the old name to the new name. If you do move some file to some directory, it'll go move the file from the first directory or the first wherever you, it'll move the file from wherever it's currently at to the directory that you specified. And again, when you're moving to a directory, that directory has to exist. So I could do something like move, right, garbage slash whatever mat_add.s, and if I say here, it'll move it to my current directory. And since I didn't specify a name, it'll use the same name as the original file. Right, and so you can see that over here, right, I guess I should probably remove mat_add.s because we didn't delete it first. Right, you can see there's no mat_add.s right now. I guess there's actually not one inside garbage anymore because I moved it. So we'll remove cmat_add.s that's here. Right, cmat_add is gone, so I can say move in like garbage slash cmat_add.s to here. And now it's here. I could also give it a new name in one command, so I could say move cmat_add.s to garbage cool mat_add.s. And now it'll move it into garbage and also change its name. If I just want to change the name of that file, right, say I could say move garbage slash main.cpp to garbage slash awesome.cpp. And you can see that if you look at garbage, main has now been renamed to awesome. Any questions? Yeah.
Does it actually?
I believe it actually renames it, so it's not as expensive as copying the file and then deleting the original. Yeah. You can move directories if you want to, but I think we have to do a different command. So if I try to say, like, I want to move garbage into examples, it's going to be like, okay, sure. So if we look inside examples, we should be able to see that there's garbage now. If we move, examples / garbage, we can move it back here to my directory, and garbage is back. Right there. Any other questions? Yeah. So question is, how do I know which directory I'm in? What command can I run to figure out which directory I'm at? Right, pwd, print the working directory. Tells me where I'm at the current moment. So if you want to create a new directory, I already kind of showed you that a second ago, it's make dir. So you make dir some directory name, and it's going to create a directory with that name, and it's going to be empty. The directory you create cannot already exist at that location. So if we currently have a directory named garbage in our current directory, we can't make another directory named garbage in the current directory, because those two names, then we'd have two directories with the same absolute path, and that can't exist. So we have, for example, over here, right, we still have garbage. So I could say something like make dir garbage / more trash, right? And now if I look inside garbage, we have a new directory. If we look inside garbage's more trash directory, there's nothing there. If you want to get rid of an empty directory, it's rmdir, the path of the directory that you want to get rid of. Again, it has to be empty. If the directory is not empty, the command is going to complain at you that that thing's not empty. If I try to remove directory garbage, right, it says, hey, can't do that, it's not empty. But I could remove garbage / more trash, and now that's gone. Yes, we'll get to that command in 1 second. So remove can be used to remove a file or directory. So if you do rm some files, it'll delete those file names. If you don't do -f, it's going to prompt you if you want to delete that file or not, which you kind of already saw before. But if you're really, really sure you want that thing gone, and there's no backsies on this, it's gone, it's gone. It doesn't get moved to the trash, it gets deleted. So be careful with this one, right? It will just delete the file, and it won't ask you if you want to delete it. You can also use rm to delete a path to, or delete a directory and all of its contents that happen to be inside of it. If you add the -r option, the -r stands for recursive, or recursive remove. It's going to delete that directory and everything inside of it all the way down. Be really, really careful when you use this one, right? If you use -f, it's not going to ask you if you want. If you're sure, that stuff's just going to be gone. If you don't use -f, it will prompt you if you want to delete a couple of things. So if we go back over here and we make our directory inside garbage again, like more trash, and then let's say we copy ECS 36B into garbage / more trash. Oops. If you want to copy an entire, oops. Wait. I want to copy -r. Oh, well, okay. We'll copy something else. We'll copy, say, whatever's on our desktop. Garbage / more trash. Okay, I guess you need a -r to copy multiple things. And now if we look inside garbage / more trash, right, we can see that there's desktop there. And apparently I didn't have anything inside my desktop, but everything got copied over. If you want to get back to the previous command, you can use the up arrow, and it'll bring you back to the previous command that you did. So you don't have to retype the entire thing. So now if I just like say want to get rid of inside of garbage, like if I just want to get rid of awesome, I can do like rm garbage / awesome.cpp. And like, do you want to remove it? And you say yes, and now it's gone. But if I want to get rid of everything inside garbage and I don't care about it, rf garbage, oops, not ls, rm. And now you can see garbage is gone and everything inside garbage is gone, right? So be careful when you use this, right? Don't ever accidentally type this. Why not? Go delete everything on your computer, right? Because you said, you know, delete everything beginning at the beginning, the very topmost level of my file system. So everything's gone now. Yeah. Mm-hmm. Yeah, so instead of doing like -r-f, you can do -rf or -fr. Either will work. Yes. So the question is, do you need the backslash after the end of that file name? No, you don't. It could be there or it could not be there. It'll work either way. It's just that when I hit the tab button, it auto-completes and puts the backslash there. Hmm? The -r stands for recursive, and it means do everything inside that directory as well. Yeah, it removes everything beginning at this directory recursively. Because if you think about your file system, it's actually defined recursively, right? Your file system is made up of folders, right? And files, right? And a folder is made up of files and folders, right? So your file system is actually defined recursively, if you think about it, right? So like if you need to like traverse your file system to find something, you probably would want to do it recursively as you go through it, right? Oh, find. Look in this directory. Is it there? Nope. Go look inside any of the subdirectories that are inside there, right? And see if I find it inside any one of those. So if you need remote access to the CSIF, like I'm doing, if you're doing Mac and Linux, you can use SSH. So you do SSH your Kerberos name at pcnumber.cs.ucdavis.edu. If you're doing Windows, I recommend using MOBA Xterm to connect. Your username is a Kerberos username. That's whatever you use to like log into your UC Davis accounts. And your password will be whatever your password is for that account. Again, it won't show up. It's perfectly normal. If you're looking for a list of valid PC numbers, you can find them over here at iceman.cs. And you can see which ones are up. And you can also see like which rooms they're at. Right? So you can use any of these numbers when you connect. You can connect to different ones in different sessions, and because the CSIF uses a network file system, let's say you do work on PC 10, right? You finish up your session and save all your files. You can then log into PC 30 and you'll see all that exact same work had been done. So you don't always have to keep logging into the same one over and over and over again. These are the computers in the basement of the Kemper. So if you want to connect to them to do your work on them, you can. If you want to work there physically, you can. It's just another option. And so like when you've seen me type, you know, these commands over here, I'm actually connected to the CSIF because I don't have Linux on my machine. I have Windows. Yeah. How do you save your work? So some things are like temporary. Like if you're moving directories, like you're moving into different directories, like CDing, right? When you come back, you're always going to start back in your home directory every single time that you connect. So if you ended your last session in /home/bob/4th of July, right? When you log back in, you'll be back in /home. You'd have to CD into bob/4th of July to get back to where you left off at. But any files that you save will still be there. Or any directories you make, those will be there as well. So this would be an example of logging in using SSH. Your username at pc.cs.ucdavis.edu. So compiling, you have a couple of different options. This is, well, I'll actually get into C++ in a second. So GCC is the compiler that's used to turn your C code into an actual executable file, because C code and C++ code, it's not runnable directly, right? Even Python code, that's not runnable directly, right? When you run your Python code, you have to pass your Python code to your interpreter. Then your interpreter would translate it to machine code and then go run the machine code. Here with C and C++, we first run a separate program, the compiler, to translate our C or C++ code into to the machine code that can actually be run, and then we'll run that executable. So GCC is for C, G++ is for C++. The options here, -G means retain the symbol tables. This is so that you can debug your code later on and still have that information there. -Wall means turn on all the warnings. So the compiler will tell you everything that looks suspicious to it. And the other option is to treat the warnings as errors. So warnings are things that the compiler thinks look wrong, but it can still translate into machine code, right? An example of something like this, right? You might have done something, if I equals 1, right? A single equal sign. Ever made that mistake? Well, in C, this is actually legal code, right? And it's compilable and it's runnable, right? But if you turn on the warnings, the compiler's going to be like, I think you meant to do equals equals here, not an assignment. You should go double check that, right? And you're like, oh, thanks, compiler. I probably really did mean equals equals here and not a single assignment. And so you can go back and fix it. But by default, it won't show you all the warnings. The other option, to treat the warnings as errors. So there are some things that the compiler just can't turn into workable C code. And I hate the fact that Control F5 and F5 are both used. Control F5 is to go to full screen, and F5 is used to refresh. So sometimes I accidentally refresh the screen when I mean to go full screen. The treat warnings as errors. Errors are things that the compiler just cannot translate into code. It might be something that's like syntactically invalid. Like if you did A plus times B, right? That's just like syntactically invalid. It can't translate it. But with the W error, it's also going to treat your warnings as errors, and so it will refuse to compile your code if it has any warnings in it. And so when I run your code for testing, I turn on both of these options, right? Because pretty much every single error you have inside your code or every single warning you have inside your code is actually really an error and something you should fix. Most of them aren't ignorable, right? Even though your code could compile. So listen to the compiler. It's your friend, even though you may hate it because all it does is complain all the time about your code being wrong. But it's probably right that there is something, there is some mistake there, and you should go to fix it. You then list your source file names, whatever the names of the source files that you want to compile together to make your program are. And then you can also optionally list -O, then the name of the executable, and it will name your executable whatever name you specify. By default, if you don't give it a name, its name is going to be a.out. Right? So if you want it to be named something more appropriate, like you're making a tic-tac-toe program, and you want it to be called like tic-tac-toe.out, you would do -O, tic-tac-toe.out. And it would be named tic-tac-toe.out instead of a.out. We will definitely get more into this, but we will also be using another program called CMake to help make everything that you have to compile a lot easier for you, so you don't have to remember all of this. Any questions? Yeah. So this just means keep around extra information inside the program so that you're able to debug the code later on. That's what the -G means. If you don't do this, like you won't have any names for any of your variables inside the debugger, or you won't be able to, like, if you specify like a file, like a line in the file that you want to stop at on a breakpoint, it can stop there, but like it won't be able to show you what actual code is there. It'll just show like the binary code that happens to be there. So at that point, like I can't really debug at all because there's nothing to connect it back to my original source code. Any other questions? Yeah. These are your source files. So these would be files like that would end in .c for your C programs or .cpp for your C++ programs. Your source files for like your Python code would be like, your .py files. Any other questions? Okay. One more command, and then I think we just have some tips and tricks. So there's CHMOD. CHMOD is used to change the permissions on a file. So this is what you can use to change who has read, write, and execute permissions to your file. Read means the person can open it and like read the file, but they can't change any of the contents that are in there. Write means that they can change the contents of the file, but they couldn't necessarily see it unless they also had read permissions. And execute means that you're able to run this file as a program, right? Like it's actual runnable code. So these octal values over here, 0 means no permissions, 1 means execute, 2 means write, and 4 means read. So you can say, CHMOD, whatever your user octal group is, your group octal number, and then your other octal. Other is people that aren't you and aren't in your group. Then some file name. There wouldn't actually be any spaces there. I've just written them there so that you can see them. And if you want to combine the options together, you more or less add them together. So if you want to give somebody both read and write permissions, that's 4 plus 2, 6 would be the number that you would use. Or if you want read and execute, 4 plus 1, 5. Or if you want all permissions, 4 plus 2 plus 1, right, 7. I think I have some examples over here. So over here, here's an example using the octal numbers. So CHMOD 740. So again, 7, the first number is me. 4 is everybody else in my user group. And the third one is everybody else that happens to exist in the world. So this is giving myself read, write, and execute permissions over this file. I'm giving everybody in my user group read permissions. So they're able to read that file, but they can't change it or run it. And then everybody else in the world cannot read it, they can't write it, and they can't run it. Any questions here? Then we'll go back to the other format as well.
What do you mean?
Your user group? User group is something that's like defined in Linux, and you probably really can't control it that much right now. But if you're working together with a group of people, you could be part of some user group inside your computer. And then you'd be able to give them these permissions that you specified. But really the ones that you pretty much care about are yourself, and safety-wise, you can just give everybody else no permissions, 0, 0. Anything else? Okay, there's another form that you can use where you can say CHMOD, and you pick one of user, group, other, or all. Then you can do plus to add permissions, minus to remove those permissions, or equals to set it to the permissions on the right-hand side. And you can say 0 or more, or 1 or more of read, write, and execute. So you can say, hey, user is you, G is the group you belong to, O is others, and A is everybody else. So if you don't give user, group, or other, or A, it's going to assume that you mean everybody. And plus add permissions, minus remove permissions, equals means set it to that permission. So if you look over here, we could say use chmod user is equal to read, write, execute some file. So on some file, right, I now have read, write, and execute permissions. Chmod g plus r some file means that's going to give everybody in my user group read permissions in addition to whatever permissions they already had, right? So if they already had write permissions, now they have read and write permissions, right? If they had no permissions, it means they're just going to have write permission at the end of this. Then they still have write permissions, right? Wouldn't change anything. Or you can say chmod a plus x. This means now everybody has execute permissions. Or if you did, a minus x, that would mean everybody loses the permissions to execute this file. Any questions? Yeah. So the question is if you remove all of your permissions from the file, are you now unable to modify the permissions for this file? No, there's another permission bit that allows you to specify who can change the permission bits, but I'm not sure which one that is. So even if you took away read, write, and execute, you could still add those back in at a later time if you wanted to. Any other questions? Yeah. Oh no, it's supposed to be lowercase, but it has a tendency to capitalize the first letter because it's the start of a sentence. So sometimes you'll see that there's accidentally things that are capitalized. Anything else? You can use either, right? The first format is really good if you want to set like everybody's permissions to be something in particular for the user group and other, right? The second form is really useful if you want to just like add or remove permissions to a single person. Or like a single group, I should say, like user group or other. Anything else? Yes. So it depends on like which group you're talking about. So if we go back over here and we do ls-l, right, that's going to be the long form. Which now it's a bit hard to see. But you can see that for this directory, ECS36B, I have read, write, and execute permissions, the first three. The user group has no permissions, and everybody else has no permissions on this directory. Or if we look over here at this file, examples.zip, it's not a directory, so there's no D there. I have read and write permissions. The user group has read permissions, and everybody else also has read permissions. So it depends on the file type, like what the default permissions are going to be. So yes, if it's not a directory, it must be a file. If it's not a file, it must be a directory, right? Because those are the only two things that can exist in a file system, right? There might be different types of files like .zip or .txt or .jpeg, but they're still just files. So a directory is like a folder, right? It's something that contains, right, one or more files, right? This transitioning to C++, it's containing these directories, which in themselves can contain more directories and more files, right? A file is just like an item on the file system that's, I guess, not a directory. It can't contain anything. It just is something like a picture or a video or a game or a text file. But yeah, I mean, like the directory can contain files, right? But directories can contain other directories as well as files. And then if you want to get help on a command, you can, of course, Google it. There's a lot of useful stuff there. But if for whatever reason you don't have connection to the internet and you still needed help, you can say man on the command, and then it will give you information about that command. You can use the arrow keys to move up and down, and Q will leave it. So like if you wanted more help on some of these functions, like man CHMOD, you'll get some information about it and like what it does and what all of its options are, right? And I did not give you like tell you everything that exists. Or if you look at something like GCC, like it's huge, like all the options that are here in terms of how it's working. Like you can see, like look at all these options. Those are just all options that you can turn on or off. Yeah. So, but you don't need to know most of them to make it work. So some tips, you can use the up key to go back to previous commands you already ran, and the down key will move you forward in your command list. One recommendation is sometimes you might have like done a command and you did it a while ago, like 20 commands ago, and you're like, oh man, I need to do that one again. And so you end up pressing like up, 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 up. Sometimes it's just faster to rewrite it. So keep that in mind, even though it can be very tempting to press up a lot. Again, pressing the tab key will also help autocomplete the names of the files for you or those paths for you, so you don't have to type out the entire thing. It makes you look like you're a really skilled typist. Again, if there's some ambiguity, right, it can't distinguish between the two, you have to keep, it'll list both of those files, and then you'll have to keep typing to be able to get the one that you want. Like for example, if we cd back into ECS 50/CMAT add, or mat add. What's there? Oh, it's under examples. CD is change directory. So if we go into CMAT add, notice that if we just did something like LSM, it can complete up to MA, but as soon as we get up to MA, it's ambiguous, right? Do we want main.c? Do I want main.o? Do I want main.s? Right? Do I want mat add? Right? But if I keep adding letters, right, it's going to be able to disambiguate more and more. So if I do, mat, now add, that's going to be mat add dot what, because there's still 3 different options. Some other things that you can do, which are pretty useful for testing, is redirecting the output of a program or redirecting the input into a program. So if you do some command and then the arrow, it's going to take the output of that command, and instead of printing it to the screen, it's going to write it into that file instead, right? So maybe you're debugging your program, right, and you want to be able to do some run and see what the output's going to be like later on, right? You can just use the arrow key on your program, or the arrow, and it will then send it to that file. If you use 2 arrows, it's going to append the contents as opposed to overwriting the contents of that file. Also, if you have some input for a program that you know that you want to run it on, you can use the left arrow key to take the input in this file like you just typed it and send it to this program to be run on, right? This is, again, like really useful if you have some test case that you know it's breaking your program, right? And you don't want to keep retyping out the same things every single time you want to keep rerunning it. You could just put it into that file and then redirect it into your program, and then it's just like you typed it all yourself. Does that make sense? So, for example, if we're here, we go back into my main directory, right? If I do like ls, right, my directory, and I say, dir contents.txt, right? Nothing showed up onto the screen. But if I cat dir contents, I can see that it listed all my files that were there, right? So it saved the output of my program into that file. But it'll overwrite it every time I do that command because I used a single arrow. So if I ls something like examples, it's now going to replace the contents of dir contents with whatever's in examples. But if I use 2 arrows, it will add it to the end. And now you can see it has a lot more stuff in it. Again, if you have some other program, which I don't have any examples on my computer right now, but if you had some program that was taking in some input, like maybe we make a quick example. So here we can cat main.c, right? All this program over here does is just ask you what your name is, and then it prints it back out. It's already been compiled, but if we wanted to compile it ourselves, we could do something like gcc-g-wall-w error, and then it's main.c, and then we can name it greet.out. And then again, it will replace it. And so now when I run this program, which you can do by doing /greet.out, it's going to ask you your name, type in your name, and it says, hello, Matthew, right? That's all it does. Nothing complicated. But what I could do is maybe I'm going to edit this file over here, right? This file over here just has my name is Billy Bob in it, right? This is the input to my program that I want to run. And so what I can do is say, /greet.out and rerun and then redirect name.txt into it, and it's like I typed the contents of that file. You see my name is Billy Bob. You can use both, so you can say, hey, take the contents of name.txt and use it as the input, and then go put your output into output.txt. Nothing shows up to the screen right now, but if I look inside output, you can see there's the output of my program.
You already have.
It overwrote it, but it was already there before, so you can see it's gone now. It exists. It has what was in there before. right? If you just redirect your output, note that, all of your output is going to be redirected. This includes all prompts, right, to enter an input. So it's asking me for my name right now. And if I cat output, you can see it says hello Matthew now. Any questions? Yes. It'll if you give it the name of a file that doesn't exist for the output, right, the output redirection, it will be created. If you give a path to a file that doesn't exist for the input redirection, it'll give you an error, right? Like if I say I want to input like georgia.txt, hey, there's no file called Georgia. That's it.
But if you were to zero,
then it would be fine to use it if I switch the arrow to go the other way, right? Because it says it will create the file georgia.txt. I have to type something, maybe their name is Georgia. And you can see that, okay, georgia.txt got created, and it has whatever it is that I just typed, and as well as the prompt, enter your name. Any other questions? Okay. That's it for working on the command line. Do make sure you do your tutorial. Do make sure to practice with it even beyond that. I know it can be really tempting to just keep, doing what you have been doing, but then you're not going to get good at it. And you can save a lot of time by practicing on the command line. One other thing that I should mention is that you can actually, again, put the commands that you want to do for some task. Hey, I got a couple minutes left. Hold on. I'm going to go all the minutes. So you can put your commands in a file and then have Bash or some other scripting language run those commands. And it can make solving certain types of problems very easy. You can also put like more complex statements in there, like if statements and loops. And so I recommend this tutorial if you want to see how to do that. So if you ever find yourself like copying things around a whole bunch in some systematic pattern, this might be useful for you. So let's talk about going to C++ from your beloved language Python. So there are quite a few similarities between C and Python, but there are also going to be a lot of differences. And most of the differences come in terms of like the details, but you'll still find a lot of the main high-level concepts like functions and types and variables, right? All those things are still going to exist. Both of these languages are also imperative languages, which means you tell the computer how to solve the problem. What do you need to do? The other two types of languages are declarative. You just tell the computer to do this thing, and it does it however it feels best. Those languages tend to be dedicated to like a certain specialized area, like databases. And then there's like functional programming, where you basically write recursive statements in terms of how to solve the problems. The differences are pretty big, though. Ideology for Python is they want to make you a productive programmer and make it so that you have to type the least amount of stuff to get your work done as possible. C's ideology is that programs should be efficient and you should only pay for what you use. They also give you a lot of control, and they put you very close to the hardware, which means you have to write a lot more to get the same amount of stuff done, because it doesn't exist yet, probably, what you need to do. Python also has dynamically typed variables, which means the type of a variable is determined as the program is running. This also allows the type of a variable to change as it's running, right? X could be storing an integer, then it could store a string, then it could store a double, then it can store your own custom type, right? It can change as the program runs. C++, however, is statically typed, which means when you are writing the program, you have to say, what is the type of this variable going to be? And then it's always going to be that, and it can never be anything else. So in C, you say int x. Great, x is an integer. It's only an integer. It can never be anything else besides an integer. Can't change. Python is also interpreted, which means when you run your program, right, you probably did like Python, right, or Python 3, the name of your Python program. This then took your program as input to the interpreter, and then the interpreter would translate it as it went through line by line into the appropriate machine code, and then it would go run it. Whereas C++ is going to be a compiled language, which means first you have to take your C++ code, run it through the compiler to make that executable, which you saw a little bit ago, and then you can go run the executable. This is going to make things a little bit faster because you only have to pay for the translation a single time, right? Get it to the machine code, and then since it's the language the computer already understands, you can just keep rerunning it. Whereas in Python, every time you run that program, you have to pay for that translation into that language, right? The analogy that I kind of give is like, you know, when you have an interpreter speaking, that'd kind of be like Python, right? First, I say something, right? The interpreter reads the language, figures out whatever it is the computer actually understands, and then speaks that to the computer to be run, right? If you guys only understood Spanish and I had a Spanish translator, right, I would speak, right? There'd be a pause. The translator would then translate whatever my statement was. Whereas I think about like the compiled language is translating a book from one language into another language, right? It all happens all at once, right? So we can translate my book from English to Spanish, and then everyone can just keep reading the Spanish version as many times as they want, right? I only have to pay that overhead of that translation one time. I will see you guys later tonight.